If you've ever tried to build a circuit board, you've probably had this experience. Every different component comes in a little hard-to-read bag, which is also not very convenient to store. All this made me want a solution to organize my PCB assembly workflow so that I could quickly and easily see the components I needed and pick them out without juggling through boxes of these bags. What I've come up with is these little plastic cassettes. Why is that better? Well, the thickness of the cassette body has been specifically designed around common label printer label thicknesses. This way, each cassette can be labeled similar to a book in a bookshelf down the spine. Then when you stack all of these side by side along a DIN rail, you can see exactly what you're after and pick that component with your tweezers and get on your way without too much fuss. But there's another problem that these feeders have been designed to solve. That is the cost of DIY pick and place machines. If you've ever looked into building your own pick and place machine, you might think from the outset that it's not going to cost a whole lot more than, say, an Ender 3 or some other 3D printer or similar robot. So why should the cost be significantly more? Well, the reason is the feeders. They often have embedded in them all sorts of sensors, circuit boards, motors, and then also interfacing hardware such as pogo pins and the like. These little feeder units can be very complicated, and that means that each one is usually going to cost, around or above $100 each. Okay, if the PCB that you're wanting a robot to assemble for you has 20 unique components on it, then guess what? Your PNP cost, the cost of just the feeders for your PNP has now become $2,000. So that's where my cassette comes in. Basically, I've attempted to achieve the same functionality as existing PNP feeders, but without any circuitry inside of the device. So these feeders are purely mechanical. The files for these cassettes are online. You can download and print and start building your own little cassettes today if you like. Organize your assembly workflow. Now, I want to show you just how simple these are to build. There's only a few parts. They're all here. From this top pin on the body, there is an arm that hinges. This is so that you can open up the gear mechanism when you need to load in a new tape. Then that arm receives the larger gear, and then in the body you put the smaller gear. Now, the tape is peeled by being pulled around a corner, and that corner needs to have very low friction so that the tape doesn't stick. So that's where we put these two bearings, which are very small. They're only 8mm in outer diameter. They have a 5mm bore, and each one comes in at 2.5mm thick, so you will need two of those to cover the 5mm clear film that we're going to be peeling off. So put those two bearings on the post there, then peel off the start of the tape, the film, and then put that where it splits, put that split underneath the bearing and wrap the film over the bearing. Run it between the two gears and out the back of the feeder. Now you can close the arm down to pinch the tape in place. These gears are able to pull the film free of the tape, and that's how the tape feeds out. So with that closed, you can truck the lid on like so, and you can bolt this all down with the 3x8 socket head cap screws. That'll close up the whole assembly and you're ready to go. As you can see now, simply rolling this top gear forwards, whether with your thumb or with a machine, will feed the tape forwards and reject the film out the back. I hope there are people out there that will find this useful. Check out the description below for the link. Please leave a comment if you can see any obvious improvements to the design here. I would be happy to work on it and make it better, and let me know what you think. I'll see you next time.